Have you ever wondered if the world around you truly exists when you aren't there to perceive it? It sounds like a philosophical riddle, a question for poets and dreamers. If a tree falls in a forest and no one is there to hear it, does it make a sound? For centuries, science told us the answer was a firm yes. The universe was seen as a giant mechanical clock, ticking away with or without our presence. But then we looked closer. We looked at the very fabric of matter itself, and what we found forever destroyed our understanding of reality. At the heart of this mystery is the Double Slit Experiment, a simple test that produces a result so haunting it famously made Albert Einstein recoil in disbelief. When we fire tiny particles of matter at a barrier with two openings, they don't behave like tiny marbles. Instead, they act as waves of possibility, passing through both holes simultaneously and interfering with one another. But here is where it turns into a psychological thriller. The moment we place a sensor to watch which path the particle takes, the mystery vanishes. The particle stops acting like a wave and suddenly acts like a solid piece of matter. It is as if the universe knows it is being watched. It's as if reality itself refuses to reveal its true nature until an observer is present to witness it. This isn't just a quirk of physics. It is a fundamental crack in the foundation of everything we know. Does human consciousness possess the power to pull reality out of a fog of infinite possibilities? Today, we explore the experiment that suggests we aren't just living in the world. We are creating it. To understand why the Double Slit Experiment is so terrifying to modern scientists, we must first look back to a time when physics seemed simple. In the early 19th century, a polymath named Thomas Young performed the original version of this experiment. At the time, the scientific community was divided. Was light a particle, as Isaac Newton had claimed, or was it a wave? Young's setup was elegant and straightforward. He shone a light through two thin, parallel slits and observed the pattern it created on the wall behind them. If light were a stream of particles, you would expect to see two bright lines corresponding to the slits. Instead, Young saw a series of many alternating light and dark bands, an interference pattern. This is exactly what happens when two waves in water meet. They overlap, adding together in some places and canceling each other out in others. This settled the debate for a century. Light was undoubtedly a wave. However, the 20th century brought the arrival of quantum mechanics, and with it, a discovery that threw the scientific world into chaos. Scientists began repeating this experiment not with light, but with electrons, the fundamental building blocks of matter. According to the classical laws of physics, an electron is a solid point of matter, like a tiny lead ball. Logic dictates that a solid object must go through either the left slit or the right slit. But when the experiment was run, the electrons produced the same wave-like interference pattern as light. This meant that matter itself, the very stuff we are made of, exists as a wave of probability before it hits a target. The solid world we touch and feel started to look like a mathematical illusion. This realization marked the birth of the Copenhagen interpretation, leading to the spooky questions that still haunt physicists today. How can a single thing be in two places at once? And why does it only happen when we aren't looking? The true mystery of the Double Slit Experiment, the part that borders on the supernatural, occurs the moment we attempt to outsmart the particle. Scientists decided to place a sophisticated measuring device at the slits to detect exactly which path the electron takes. They wanted to see the moment of choice, but as soon as the detector was turned on, the universe seemed to change its rules. The electrons stopped behaving like waves and began acting like solid bullets, forming two simple lines on the back screen. The interference pattern, the evidence of their wave-like nature, completely vanished. This phenomenon is known as the observer effect. It implies that the act of measurement or observation collapses the wave function. Before we look, the particle exists in a state of superposition, a ghostly haze of all possible locations. But the moment we interact with it, the particle is forced to choose a single position in our physical reality. This leads to the measurement problem, one of the most debated topics in all of science. It suggests that reality is not an objective fixed thing that exists independently of us. Instead, reality is a participatory process. What makes this even more mind-bending is that observation doesn't require a human eye. Even a mechanical sensor that merely records data without a human looking at the screen is enough to collapse the wave. This suggests that the universe has a fundamental awareness of information. If information exists about which path a particle took, the particle must become real. This bridge between information and matter is the foundation of quantum mechanics, and it leads to a haunting realization. The world we see is only one version of an infinite number of possibilities, brought into existence simply because we decided to look. The implications of the observer effect have led some of the world's most brilliant minds toward a chilling conclusion: that our reality might be a sophisticated digital construct. This is the core of simulation theory. In a high-end video game, the computer only renders the environment that the player is currently looking at to save processing power. When the player turns around, the world behind them exists only as lines of code, not as a fully realized 3D image. The double slit experiment suggests our universe operates the exact same way. Matter remains in a wave state, unrendered code, until an observer forces the system to calculate a specific position. But the mystery goes even deeper with the delayed choice quantum eraser experiment. In this advanced version, scientists found that they could observe a particle after it had already passed through the slits. Shockingly, the particle seemed to change its behavior in the past to match the observation made in the future. This implies that time itself might not be a straight line, or that information can travel backward to overwrite history. It suggests a retrocausality that defies every logical rule of cause and effect we hold dear. This leads to the many worlds interpretation. Some theorists argue that the wave doesn't actually collapse. Instead, the universe splits. In one timeline, you see the particle go left, and in another, you see it go right. We are merely navigating one branch of an infinite, ever-growing tree of realities. Whether we are living in a matrix-like simulation or a fractured multiverse, the double slit experiment proves that the solid world is a thin veil. We are not just inhabitants of reality, we are the very engine that drives its manifestation. If consciousness is the key that turns possibility into matter, then we are far more powerful and far more mysterious than we ever dared to imagine. The double slit experiment remains the most profound paradox in the history of science. It forces us to confront a reality that is far more fragile and strange than it appears on the surface. We are left with a haunting choice. Either the universe is an objective machine that we simply do not yet understand, or it is a subjective experience that requires our presence to exist at all. If the latter is true, then we are not merely spectators in a cosmic drama. We are the very reason the stars shine and the planets solidify. This experiment is a reminder that at the smallest level, the universe is a sea of infinite potential, waiting for a conscious mind to call it into being. As we continue to peer into the quantum abyss, we must accept that the bridge between the observed and the observer is the most important link in existence. Perhaps reality isn't something that is happening to us. It is something that is happening because of us. In the silence of the quantum world, the message is clear. The universe is watching you, just as much as you are watching it.